Hello everyone, welcome back to What's Inside. This is episode 6. If you made it this far, congrats. We're past the halfway point this season. Today, we're going to be going over something a bit special. It's this little chip right here. I don't know, it looks like a little centipede, and we'll get over more what it does later. But for now, we can tell you.
So what this is, it's the HCH, just a piece, and what it does is that it converts 8 output signals at once, and it converts it into electrical signals for the other components. And yeah, there's only just one component that you need, and it just controls all the signals to the LEDs.
Yeah, let's get into the analysis now. We'll tell you more.
Hey everyone, welcome back to the analysis portion of this very cool piece right here. Looks like a centipede like Josh was saying. So the full name of this piece is the 74HCH HC595. And so what it can do is that it sends data one at a time and it outputs 8 signals simultaneously, which multiplies your output capacity. And for example, with 3 Arduino pins, you can control 8 outputs with 2 chain chips, 16 outputs, and if you keep going, you can control hundreds and hundreds of outputs with just these 3 wires.
So how does the 74HC595 chip work? Let's break it down into 2 major sections. There's a shift register, which serially stores the 8 bits one by one. And then there's also the output latch, which holds the 8 bits for output display. You load 8 bits serially into the shift register. Once loaded, a latch pulse copies the bits to the output register, and then outputs are updated instantly and simultaneously. This separation ensures your outputs don't flicker or glitch while new data is being shifted in.
And so there are a couple of pins to this very interesting piece right here, and so there's a total of 8. So the first one is the Q1, which is the VCC. Q2 is the Q0. Q3 is the SER, which is also known as the DS. Fourth one is the OE, which enables. Q5 is the RCLK, which is the latch. 6 is the SR, and then 4 the clock. And 7 is the reset, and finally 8 is the ground for Q7 data out. And there's also the same things on the flip side. And what it essentially, like the other pins on the other side, it does the same things as the first 8.
Now let's get into electrical characteristics. So for the output operating voltage, it's usually 2 to 6 volts. Typically 5, and for the max output current, it's 35 milliamps per pin. For the propagation delay, it's 20 nanoseconds, and for fan out capability, it's high multiple chips chainable. And as for the around wiring, we'll connect the shift register to an Arduino using 3 digital pins. William can tell you about these pins.
Yeah, so there's a couple of pins here. There's the pins from the Q0 to 7, which are the LEDs, the output pins. The 13th one is the OE, or the enable one, which is the Arduino ground pin, which enables the outputs. The 10th pin, which is the 5 volts pin, which is stable reset. The 12th pin here is also the 12th pin on the Arduino pin, which is the latch, and etc. And so we have a basic operation sequence here. So the first step is send the data bit to the SER. Step 2, pulse the clock, which shifts the data in. Then repeat this 8 times, pulse the R clock to transfer to output. Step 5, which is the final step, all of these Q0, Q7 outputs now reflect the 8 bits that were sent. And this cycle can happen thousands of times per second for very smooth animations.
And now let's run you through some example Arduino code. It'd be something like int data pin equals 11, int latch pin equals 12, and int clock pin equals 13. Void setup pin mode. Here we can you can email us if you want to see examples of code. It's just a bit tricky to tell you about code when you can't really see it. But each value from 0 to 255 lights up a different pattern across 8 LEDs. And some live demo ideas that you can go through with are some binary counters, LED chase animations, some bar graph displays, or scrolling text. And there's a lot more to tell all of you about, such as daisy chaining multiple of these, as well as inside the ICs and troubleshooting tips, and a bunch of summary stuff. But for now, this is just the centipede looking chip. As always, remember, y'all stay curious because that's what's inside. Thank you for tuning in to this episode 6, and we'll see you next time. Hopefully you learned something. Hopefully we'll see you next time.